now we're going to use the product rule. So when you have a function, okay, and it might look like the one below here, f of x is equal to the bracket multiplied by another bracket. So basically it's like two functions multiplied together. That's the product of two numbers. So we employ the product rule. Now you could obviously go off and multiply out the brackets and simplify it and then just get the derivative of that. But what happens if I put a square on that bracket and I put a cubed on that bracket? You're certainly not going to go off and square out the first bracket, cube out the second bracket and multiply them all together. You'll be there all day trying to do that. So obviously it's going to be much quicker here in this scenario to use the product rule. So when we use the product rule, I'm going to call the first bracket u, and it's going to be multiplied by the second bracket, which is now going to be v. So I've decided which is u and which is v, right? If you do the reverse of that, it doesn't matter. U multiplied by v is v multiplied by u. So now we're going to use our product rule. The formula for the product rule is on page 25 of the log tables. There's your formula. The derivative of the function, dy dx, is going to equal u by dv dx plus v by du dx. I would advise you to go and learn that formula off by heart. Okay, so let's look at the first example. Let's say I give you the function 6x, a bracket, 3x squared plus 2. So again, this looks like a bracket by a bracket. Again, you could just go off and multiply it out, okay, and then get the derivative of it. You'll get the same answer, but I'm going to show you how to use the product rule. So first of all, I'm stating that the 6x is going to be my u, and the second bracket here is going to be v. So here's my product rule formula. Right, the derivative, so f dash x is going to equal u dv dx plus v du dx. So I've established what u is, okay? So now that I know that u is going to be 6x, I'll put that down and I have to go and find du dx. Then I know what v is 3x squared plus 2, so I'll have to go off and get dv dx, differentiate v with respect to x. So that brings us over here. So u, I said, was 6x, and then I go off and I get the derivative of u with respect to x. So du dx is going to be 6. V was 3x squared plus 2. Therefore, I'm going to get the derivative of v with respect to x. And you're going to get 6x plus 0, which is just 6x. Lastly, now I'm going to put them back into the formula. So again, remember what the formula was. Okay, so there's my formula for the product rule. So u was 6x, so it's going to be 6x multiplied by dv dx, which I said was 6x, plus v, which was 3x squared plus 2, by du dx, which was 6. Tidy this up. 6x by 6x is 36x squared, plus 6 by 3x squared is 18x squared, plus 12. Now we can group the two x squareds together. Okay, and you're going to get 36x squared plus 18x squared is 54x squared. Sorry, 54x squared plus 12. So there's my derivative of the function using the product rule. 54x squared plus 12. Now, let's say you didn't use the product rule and you went and you multiplied out those brackets. This is what you get in your next line. So the original function was 6x by 3x squared plus 2. So if I multiply out the bracket, I'll get 18x cubed plus 12x. Then if I want to get the derivative of that, 3 times 18 is 54 by x and reduce the power, so it becomes a 2. And the derivative of 12x is 12. Okay, so of course you can do it that way if it's as simple as that to do it. But again, if it's more complicated, you have to use the product rule. Okay? And sometimes the question will tell you that you must use the product rule, so you don't have a choice. Okay, again, let's look at this example. So again, I have a bracket by another bracket. So I'm going to state this is going to be my u and this one's going to be my v. So it's a product rule because I've got one bracket multiplied by another. So u multiplied by v, so it's the product rule. Okay, so again, remember your formula for g dash x. It's going to be u times dv dx plus v times du dx. So u is x plus 1 to be squared. And we go off and we get du with respect to x. So du dx is, bring down, and this is where you employ the chain rule, so bring down the 2 in front of the bracket, reduce the power to a power of 1, and then then get the derivative of the inside of the bracket. Well, the derivative of x plus 1 is just going to be 1. Okay, so that's 2x plus 2. Then v is 2x squared minus 3x, so dv dx. This is where you use the chain rule. You're going to get 3 times, sorry, I need a little bit more space here, so I'm just going to come down here. You're going to get 3 times the bracket, 2x squared minus 3x to the power of 2, and then differentiate inside the bracket. So you'll get 4x minus 3. Right, so we plug it all back into the formula. Right, u dv dx plus v du dx, and this is what we'll get. So the derivative of g dash x, u is x plus 1 to be squared, so that's that. dv dx was this. Okay, and you can multiply the 3 into that bracket if you want. You can't multiply it straight into this one, obviously, because of the square on the bracket. But we'll leave that for the time being. Plus, so there's your plus, v, this was my v, du dx then was 2x plus 2. Alright, then you can go and tidy all that up. Alright, you can leave it with the squares on the brackets, and you can leave it with the cube on the bracket. Okay, and just rewrite it. So I'm going to multiply the 3 in front there by the last bracket. So I'm going to multiply 3 by that bracket just to tidy it up. Okay, so my next line is going to be 3 times 4x, which is 12x, minus 9. So I've multiplied in by 3. That gets multiplied by an x plus 1 to be squared, which gets multiplied by 2x squared minus 3x, all in a bracket to be squared. Plus, underneath that then, I'm just going to put the 2x plus 2 by the other bracket, which was 2x squared minus 3x cubed. And I am not, under any circumstances, going multiplying all of that out. I'm going to leave it like that. Okay, but that's just another example of when you're given a complicated initial function like that. You're not going to go multiplying out the brackets and splitting the brackets and all the rest. It'll take forever. Okay, now usually the question, if it's as complicated looking as that, usually they'll say leave your answer in the form of something. You know, and the form of something would probably look like that last line that I've done there. Okay, so that's using the product rule. So what I want you to do now is turn to page 352. I want you to do question 1, part 2 and part 3. Okay, it's asking you to differentiate with respect to x the following functions in 2 ways. 2 ways means one of the ways is going to be multiply out the function. Okay, like as in multiply out the brackets together and then go off and differentiate it that way. The second way is going to be to use the product rule. Alright, either way you'll get the exact same answer. So that's question 1. Question 2. It's the same thing again, it's the exact same thing again, multiply it out. Alright, so I want you to do part 1, 2 and 4. Come down then to question 4, and I want you to do part 2, 3 and 5. And is there anything else that you can do there? No. Okay, so off you go, do those using the product rule or multiplying out the brackets, and then come back and look at the solutions. Okay, so these are the solutions. So for question 1, part 2, so we are going to use the product rule first. Okay, so this is using the product rule. So again, it's going to be your u by your v. So u was x to the power of 9, v is going to be x to the power of 6. So there's u by v dx, which works out to be 6x to the power of 5, plus v, that's your v, and this is du dx. Okay, tidy it up and watch your rules of indices for the powers of x. Okay, you should get out 15x to the power of 14. That's using method 1. Method 2 then, they said multiply out the expression first before differentiating. Well, if you multiply x to the power of 9 by x to the power of 6, you'll get x to the power of 15, and then the derivative of that is 15x to the power of 14. Okay, you can see you get the same answer. Part 3. Again, use the product rule the first time, so this is where the product rule is being applied. So it's going to be u by dv dx plus v by du dx. Multiply it out, tidy it up, and you'll get 24x minus 7. Part B then, multiply out the brackets first, and you should get 12x squared minus 15x plus 8x minus 10, tidy it up. 12x squared minus 7x minus 10, then go off and get dy dx, and you'll still get your 24x minus 7. Question 2. Again, using the product rule first, so f of x was equal to 4 bracket root x plus 3 by x squared. Again, remember the square root is the same as x to the power of a half, so just remember that, okay? So we use our product rule again. So this is going to be your u multiplied by dv dx plus v multiplied by du dx. Okay, so that's du dx there, and if any of you are unsure of how they got 4 by a half times x to the power of minus a half, well, remember your u was 4 root x. That's the same as writing 4 times x to the power of a half. Okay, if you get the derivative of that, so that's going to be a half times 4, okay, by x to the power of a half minus 1 is minus a half. Sorry, it's just being cut off. A half, there's a power of a half there anyway, okay? 4 multiplied by a half is 2, and that's x to the power of minus a half still, okay? That's the same as writing, well, they do it down below underneath here, okay? So remember now, this here is being multiplied by x squared. That was in front, okay? There's the x squared, so don't forget that. So if you multiply that by x squared by 2x to the power of minus a half, that's going to be 2 times x to the power of, add the two indices, 2 plus a minus half is going to be 1.5, or 3 over 2. So that's where they're getting this from. 2x to the power of 3 over 2. Okay? And it's the same here. They just rewrite root x as x to the power of a half. And when you're multiplying into this first bracket here by the 2x, just remember your rules of indices, because that's an x to the power of 1. This is an x to the power of a half. So x to the power of 1 multiplied by an x to the power of a half. Add the two indices, 1 plus a half is 1.5, which is the same as 3 over 2. So that's where they're getting the power of 3 over 2 from. Now, when you'd multiply out the brackets doing it method B, so multiply out the brackets, you'll still see that you should get 10x to the power of 3 over 2 plus 6x. Okay, I just don't have the solution written up there, but you should get out the same answer. Part 2 then, g of x was equal to 5 root x plus 3 by x cubed. So again, same thing, product rule. So that's your u, that's your dv dx, that's your v, and then this is your du dx. Okay, and again, just watch the rules of indices. Next line then, we are tidying up the first bracket there and there, multiplying into that bracket by 3x squared. Remember, root x is x to the power of a half. Okay, so when you multiply x to the power of a half by the x squared outside the bracket, remember you're adding the two indices. 2 plus a half is 2.5, or as a top-heavy fraction, it's 5 over 2. So that's how they're getting 15x to the power of 5 over 2 plus 9x squared. And then your right-hand side simplifies down to 5 over 2 times x to the power of 5 over 2 as well. Just watch your rules of indices. Okay. Then they group together the x to the powers of 5 over 2. So that's 15 plus 5 over 2 works out to be 35 over 2 times x to the power of 5 over 2 plus your 9x squared. And again, if you had multiplied out the brackets first off and then go off and differentiate it, you'll get the exact same answer. Just watch your rules of indices. Part 4, root x plus 3 in one bracket, and then 3x minus 2 root x plus 8 in the other bracket. Again, just watch your rules of indices. So that's your u, that's your dv dx, that's your v, and that's your du dx. Okay? Remember, all the root x's are the same as x to the power of a half. So just watch all the signs, tidy it all up, and you should get out 9 over 2 times x to the power of a half plus x to the power of minus a half plus 7. Sometimes they will ask you to express your final answer with positive powers, in which case if you have x to the power, so I'll just do it here, if you have x to the power of minus a half, that's the exact same as writing 1 all over x to the power of a half, which is the same as writing 1 all over root x. Okay, if they asked it to give it in a certain way. If they don't, you can leave it as the negative power. Question 4 then, straightforward, you just had to use the product rule. They don't ask you to go and multiply out the brackets at all. So using your product rule, you had to do part 2 there. So g of x was x squared minus 1 in one bracket and then 5x minus 2 in the other. So again, it's a u by a v. So that's your u dv dx plus v du dx. Multiply it out, tidy it up, and you should get out 15x squared minus 4x minus 5. part 3 of that question. So your first bracket was 1 minus x squared. Your second bracket was x squared plus 5x plus 3. So again, u dv dx plus v du dx. Alright, so you've put it all into the formula, tidy it all up, group your like terms together and simplify it. Okay, and you get down as far as here. The last one then, part 5. First bracket, 3x squared minus 2x plus 5. The second bracket is 4x squared plus 3x minus 1. Again, it's a u by a v, so it's product rule. So u dv dx plus v du dx. Tidy it all up, a lot of multiplication there. Okay, split the brackets, tidy it all up, group all the like terms, and you should get down as far as here. Okay, so that's the product rule. Make sure you have gone through all of those solutions and that you got them out.